name is Antal Bese, a solution architect at Nokia, and today I am presenting you our demonstration of the core slice automation journey we have. As increasing popularity of core slicing and end-to-end network slicing, we have several insights and experiences from the field, which I would like to share with you today through our journey in a major US customer. We have several problems we had to assess with that customer case, and I would just like to go through all those one by one. The first is that we have to have a solution for the case when we have a lot of network functions in the core network in the 5G core, and in that case we have only a small amount of maintenance window to operate and configure all those network functions at once. How to do that, how to fit into that maintenance window, that's a problem. The other, maybe not surprisingly new information is that not every CSPs have Nokia only and exclusive Nokia 5G core network. So it's always a case that we have, or it's a very frequent case that we have multi-vendor environment, so we need to prepare for that. How to prepare with slice orchestration, core slice management with that problem. And then the end, when the core slice is about to be created or the slice is operating, we have to have a solution to observe and make an assessment or make an assurance step, even a closed loop action when we have the slice operating. We have solutions for all that problems. The first, we would like to present a new operational API, which is doing a controlled rollout, which means we are creating the slice first in a small subset of the core network, then we are making it bigger, we are expanding it, and it's actually beyond the standards. We are using several custom-made operations, 3GPP standard extended, and this is what I'm going to do and present to you. The other solution is that we have a multi-vendor environment in our demo environment. In that case, we have a 5G core network from Nokia, and we have a 5G core from another operator or other vendor. And this third-party vendor, we have to prepare for. We have to have integration. We have to have a solution to make it possible, and that's what I will show you. The other part, I will show you our preventive assurance and predictable environment, which is doing the core slice assurance. And of course, I need to mention that if you have static slices already in your environment, when you would like to introduce core slicing, then we have a solution for discovering those slices and even managing those static slices and making them dynamic in your environment. So let's look at our demo environment. We have in the middle, in the center, our Nokia Core Slice controller. This is a digital operations center-based solution which has three main components. It has a Nokia Orchestration Center, Unified Inventory, and Nokia Assurance Center. Our Network Function Management function solution is Nokia Mentor ENM, which is deployed in our laboratory. And we have a fully operational 5G core network in our laboratory back in Budapest. So this laboratory has all the network functions, but we will configure and handle only the blue boxes, so several AMFs in the laboratory, and we will do the configuration of those only. We have a third-party 5G core as well. It's, for obvious reasons, simulated, but we have an NFMF solution from the third-party vendor, and we have the SMFs located in the 5G core of that third-party 5G core network. Our northbound interface, so the NSMF, is now simulated, so we are not using our digital operations-based solution, because we are concentrating only on the core and SSMF, so all the northbound interface communications will be visible, so you can see in our user interfaces, and you can even follow what's happening in the background. So what we will do is to create a tracking area-based core slice, first in a small small area, then we are going bigger and expanding the slice. So I'm going through our feasibility, slice orchestration, and then the preventive assurance steps. The first step is to create an order, making a feasibility check, so we can decide which network functions are feasible in the core network, which network functions can take the slice profile we are actually trying to use, and which SLA we would like to create. So I will create a new order here in our Nokia Orchestration Center order hub. So first, I need to fill up all the slice profile lists parameters, like I need to specify the SNSSAI, I need to tell which PLMN I would like to use, and most importantly, I have to tell which coverage tracking area list I'm using. At the moment, I will use only one tracking area. This is 100-100, because we are in a laboratory environment, not in a real network environment. So I'm setting all the performance requirements, like throughput per user equipment, maximum number of PDU sessions in a slice, and number of EUEs. Once I have all those set, I can send in the request, and I can check the result. This is important to highlight that the feasibility check, which is running at the moment, is not changing the network, it's not touching the environment. We are using the data stored in the UIV, and we are just going through specific feasibility conditions, like we are checking the configured tracking areas, checking the DNS, and checking how the static data in the UIV is matching to our needs. Another important highlight is that we, at the moment, using the feasibility check out of the slice creation procedure, which is usually mandated by 3GPP to be done during when you create a slice. We do that feasibility check just to have an insight, just to have a list of feasible network functions. So while my order is running, I'm copying here the order ID, because that's what I need in the northbound interface to check the feasible network function list. So you can see here our workflows, what steps the workflow does, what feasibility checking conditions we are doing, like checking the SMFs, validating the DNS, validating the SMF categories, and the tracking area identification groups. Order is completed. So I have to check. The response, unfortunately, is not visible in the order hub, so I have to use a simulator to get the result. And you can see the slice feasibility check, the core slice feasibility check has finished. The feasibility status is true, so we have a feasible slice creation request, and we have a list of network functions here. All the network functions which are good for that slice creation request. So it helps the operations team to choose which network functions they would like to use for the initial slice creation. So we go back to the order hub and start creating the initial core slice. Again, I'm using slice creation request from the order hub in the Nokia Orchestration Center. Similarly to the feasibility check, there is only one difference, that I'm using our custom-made operations, which is the create managed object instance test operation, which is intended to create a slice on the listed network functions. So first I need to fill again the slice profile information, just I did before with the feasibility check, adding the coverage tracking area, setting all the performance requirements, things like that. I have to do that again, but normally it's done by the northbound API, so it's not done by manually. The new thing here is the rollout operation. So I have a new rollout operation section, so I can specify in which network functions the core slice should be created. So I have chosen 2 network functions out of the feasible network functions list, and I'm sending in the order with those specified in the request. If we are checking the processing in the order hub, we can see that the slice creation has started. We are creating a new core NSSI in the network. And to do that, we are using the NFMF solutions one after each other. So we are using the Nokia NFMF and using the third-party NFMF to manage and configure the network functions in the network. And of course, we are calling the very same feasibility check scenarios, the feasibility operations, as we used to when we called the feasibility check separately. Here we will see the new core slice created. I'm using now filter, so the BBB, which is our designated SD value, should appear here. Just a sec. Okay, so our core slice has appeared in the UIV. So we can see that the slice creation is progressing. So we go to the topology view and check the core slice. How does it look like in the repository? First, and most important, the slice is still deactivated. The slice is not active, but we have the configuration in place. So we can check that as well in our database. So the slice is operating, working, available, but still deactivated, which means in our solution that we are configuring the SMFs, but not configuring the AMFs. The reason behind is quite simple. We would like to keep a 3GPP defined procedure to have a deactivated slice at the beginning and just to be able to activate it. And to activate it, we will configure the AMFs. So in that case, the subscribers and the user equipments, of course, can take the slice, then can use the new slice created. So if I go to the AMF and check the data in the AMF, you can see that this AMF has several network slices already configured, but our slice with the 3Bs is not configured here. So I can check here with the core slice logical that our slice has that ID, that SNSSAI, and it was not visible in the AMF configuration yet. So what I have to do to make it happen is to activate the core slice. I open the slice and copy the slice ID and go to the order hub again, issue a new order to activate the slice. We are using the modify MOE attributes operation for that. And of course, we have to assign and give the subslice identification, and the administrative state is unlocked, which means in CGPP terms that we are activating the slice. What will happen is that our core slice is going to be activated, and our AMFs will be configured through the NFMF solution or Mentor ENM. So if I'm going to the UIV, so the intelligence hub, I should be able to see that this core slice logical is going to activate it after a while. Yeah, this happened. So if we go into the details, we can see that the slice has been activated. The administrative state has been changed to activated, and the slice is completely operational and working. So this is the point when the CSPs go to the operation, try the slice, check the QoS settings, check the SLAs if they are met, and in that case, they can decide if that slice is good enough for that kind of request. So that kind of QoS parameters they were requesting for. They can try out and verify in a small environment, in a small site, for example, that the slice is operational and that's doing the thing they wanted. So if we go to the AMF, here we should see that the new slice has been configured. and the new SNSSAI value is appearing in the configuration. The next step, when all these verification steps has been completed, is to make the slice bigger, expand it, and made it available in this whole tracking area. And to do that, I'm not using now the order hub, but I'm using our Postman or simulation tool. So I have to use this Postman tool to create and expand the core slice, make it bigger, make it available in a bigger environment. First, I need to authenticate into the order hub in the orchestration center and send in modify my attributes operation, which is all prepared here for that purpose. So normally we will use that in the noseband interface, but for the clarity, I'm showing you the request. So you can see the very same slice profile attributes are visible here as we were using in the initial steps. And the difference is that we have a rollout operation with all the core network functions we would like to have the core slice available on. Okay, I'm sending in the request, so let's check it in the order hub. Okay, a new request arrived. And we can check here what input parameters I gave to the order. The same SNSSAI as before. The same performance requirements and the list of network functions. What I expect is that at the end of the operation, that core slice will expand like boom, having more network functions, more AMFs, more SMFs connected to the core slice logical. So we just need to wait for the operation to finish. So what happens in the background that the core slice controller is going through the list of feasible network functions, actually executing the same feasibility check as before and going through network function by network function, which we specified in the request, and creating a new configuration snippet and using the NFMF solution respectively. For the Nokia AMF, we are using Nokia Mentor ENM, and for the third-party SMFs, we are using the third-party SMF's NFMF solution. And if I'm refreshing the UIV, yes, I have all the network functions connected to the core slice, which means we have reached the designated size of the slice. All the network functions are connected to the core slice, so we can use the slice in a tech level or even in a bigger country or nation level. So that was the reason, that was the goal we had at the beginning. So we have a bigger slice, so operation team can provision the slice to the subscribers, and all the subscribers can use with their own devices the new slice SLAs. And how to observe if any problems happen, or how to observe the slice SLAs. We have in our assurance center an AI ops dashboard, which is based on AI predictions. You can see here that there is a forecast, there's a confidence in the forecast, there is a prediction duration. So we have the network level performance measurements coming into the assurance center. We have a nice graph drawn out of those performance measurements, and at the end we have a prediction which is based on our predictive models. So we can see what number of users will probably use that core network, what is the predicted throughput, and how our CPU usage may be. And of course, we can go further. We can check what is the actual situation with the core NSSI, how many connected devices we have, what is the current latency, what is the throughput, and even we can see here the forecast models to see what is the predicted number of users, predicted latency, throughput, you name it. And beside that, we have a very similar topology, core and SSMF topology here. So you can check what's happening around the core slice. You can even see a small red R here with the core slice, which means that there is some problems. We simulated that problem in the background with a script, so even the connected devices are simulated with a simulator, so all devices are actually registered to the network. But we have some problems. How to manage that problem? You have to drill down and observe it a bit more deeper. So you check, and you can even check the Kubernetes cluster level details, like we can see the nodes, the namespaces, the Kubernetes pods, and the memory usage, CPU usage, all those detailed here in that dashboard page. And of course, you can check the top CPU usage, the top memory usage of the containers and pods here. And if there is any problems like out of memory kill events happen, then you can go there and check which network function does that, which network function is problematic, which network function is needing a bit more attention. This is important for you to check, and if you can see those data, you can fix that problem. And of course, you can even build up, and we can help you in that, to make a closed loop action to recover from that situation. As we are reaching the end of the demonstration, I would like to draw your attention all the key takeaways we had in the presentation and the demonstration. First, important to mention and highlight, the slice automation goes beyond standards. We have to be creative. We have to invent some new ways to help the operations team to introduce a new core slice, a new end-to-end slice. The not surprising news is that we have multi-vendor environments here and there, so we have to be prepared for the multi-vendor situations, and we are prepared for in our solution to have that happen. You have to think, you have to plan your feasibility check, because you can use the static data from the UIV database or can use the dynamic data from the assurance center. And it's up to you how to design that, but openness is key. So you have to design it, you have to work in a collaborative mode to do that. The other one is that everything goes pre-integrated in our Nokia Core Slice controller solution. Thank you for your attention. Enjoy the event.